Okay, now we're doing question 3 on section 3.5, and we have to find the dy dx, or the first derivative of this function. And so we're going to use the product rule. And we'll hold x squared constant, take the derivative of cosine of x, but the derivative of cosine of x is minus sine of x. And now we'll hold plus, and so we'll hold cosine of x constant, and we'll take the derivative of x squared, but by the power rule, that's 2x. So now let's clean this up. I'll always lead out with a positive. So the positive term here is 2x cosine of x. And why lead out with a positive? It's just easier to read. It's in our comfort zone. It's nicer. So x squared sine x. And we're done. There's our dy dx. Okay, now we're doing question 33, and there's two parts, A and B, and so we're doing A now. And let me point this out. We need three identities. We need to find the second derivative of this, and to do that we need three identities. First of all, the derivative of the cosecant of x with respect to x equals minus cosecant x times the cotan of x. And also the derivative of the cotan of x with respect to x equals minus cosecant squared of x. And finally, cotan squared of x, the identity for that is cosecant squared of x minus 1. Now with those three identities, we should be able to find the second derivative of this. So the first derivative, y prime, equals, and we're given that, aren't we, minus cosecant of x times cotan of x. Now, so y double prime equals, and we'll hold, first of all, we'll stick that negative right there and get rid of it out of our way. And we'll hold cosecant of x constant. And then we'll take the derivative of cotan of x, which is minus cosecant squared of x. Now, we'll hold cotan of x constant, so I'll do that down here, plus cotan of x. And now we'll take the derivative of cosecant of x, which is minus cosecant of x cotan of x. Now let's close this. So this equals, and now a minus times a minus is going to be a plus, and so we get a plus cosecant cubed of x. Now here, we've got a minus times a plus. That's going to be a minus times that minus is going to give us another plus. And we're going to have cosecant of x cotan squared of x, which equals cosecant of x, cubed of x plus cosecant of x times, and we'll use this identity for cotan squared of x, which is cosecant squared of x minus 1. And now we'll multiply that out, and we get cosecant cubed of x plus secant and cubed of x, because we have this times it's squared, itself squared, and so that's going to be cosecant cubed of x, and then times cosecant of x times minus 1 is minus cosecant of x. So it turns out we have 2 cosecant cubed of x minus cosecant of x, and we're done. That's our y double prime. Now we're going to do part B of question 33, and we have to find y double prime. Well, the first thing to do is find y prime, and so that's going to be secant of x tan of x. And now to find y double prime, we'll use the product rule, and we'll hold secant of x constant and take the derivative of tan of x, which is secant squared of x, and plus, and now we'll hold tan x constant and take the derivative of secant of x, which is secant x tan x. Now, by the way, I have these identities here that we're going to have to employ. In fact, we've been employing them. So this equals, well, secant of x times secant squared of x is secant cubed of x. And here we have plus secant of x tan squared of x, tan x times tan x. Well, secant cubed of x plus secant of x, and now we'll replace tan x, tan squared x, with its identity, which is secant squared x minus 1. So now we have secant cubed of x plus, and secant of x times secant squared of x is secant cubed of x, and secant of x times negative 1 is negative secant of x. So it looks like we have 2 secant cubed of x minus secant of x, and that's y double prime, and we're done with that. Now we're doing question 39, and we have to find the flat spot on this graph if we were to graph it, and if there is one. So how do we do that? Well, we'll take a derivative, set it equal to 0, and if we come up with a solution in this interval, then that's where the flat spot will be. That's where the slope of the tangent line will be 0. So y prime equals derivative of x is 1, derivative of sine of x is cosine of x. So now we'll set y prime equal to 0. That is, we'll set cosine of x plus 1 equal to 0. So cosine of x equals negative 1. So the solution to that is, on the interval 0 to 2 pi, x must equal pi. So there's a flat spot at x equals pi.